we've already seen one animated visualization from Hans Rosling when he did that animation over time, but a number of data visualizations use animation as part of the method for displaying the data. So this is an animation by Periscopic about gun deaths in 2013. So I'm going to show you the visualization here. Each one of these arcs represents one gun death, and these are both intentional and accidental gun deaths from 2013. And what the folks who did the visualization have done is they have put the arc out to the point when the person died, and then they've continued it on to as long as they might have been able to live had they not died of a gun death. And then they're adding up the total number of stolen years. So this data visualization relies on data about gun deaths from a particular year. And it also relies on some statistical projections. So for each one of these people, like this 29-year-old man who was killed on July 17th in Detroit, Michigan, they found that statistically he might have lived to be 88 and died of natural causes. Of course, they don't know actually how long he would have lived, but they're using statistics to make those kinds of guesses and sort of humanize the data even more. Some of the arcs have names from news stories, and some of them just say, you know, a person, a 38-year-old man. Sometimes they have names. Another animated data visualization, this one is by Fernanda Villegas and Martin Wattenberg. Martin worked on that visualization that I showed from Zan Armstrong earlier. And this visualization shows the wind at a particular time. So it's showing how the wind is moving across the United States and where the wind is quickest, the direction of the currents. It's really interesting to watch when there's a big storm or a hurricane happening, but it's an animated visualization that lets you see something that is moving. This is an interactive visualization. So this data visualization is going to interact with the location services on my browser and orient itself to the area where I am. So I live in Hennepin County, so it has centered the map on Hennepin County, and then the entire article is referencing that county. So it's saying Hennepin County is about average for income mobility. It's better than about 49% of counties. And then even the paragraphs in this story have changed themselves to be about that area. If you're poor and live in the Minneapolis area, it's better to be in Carver County than in Ramsey County or Hennepin County. So not only is this an interactive data visualization, it's an interactive piece of data journalism. And it says, feel free to change to another place by selecting a new county on the map or using the search boxes throughout the page. So we could go look at Los Angeles County, where I lived when I was in graduate school, and it would change to an interactive map here, and every paragraph would be about Los Angeles County. Another interactive data visualization that I love is the racial dot map. So here's the website for the racial dot map. This is based on 2010 census data, so I'm very excited for it to be updated with the 2020 census data. The people who made the visualization have disaggregated the data. So it was collected at the census block level, and we only knew how many people lived in a particular block and how many people of a particular race lived on that block. But they've deaggregated the data to create one dot for every person in the entire United States. And again, we could interact with this visualization. We could try and zoom in on the Twin Cities area. I'm going to add map labels so that I can kind of see where some things are. We could try zooming in on St. Paul, and maybe we could find the area where St. Thomas is. And we can see patterns of where there are many Hispanic people or many Asian people, many Black people. And these patterns are influenced by history. So there used to be rules governing where people of certain races could live. And even though those rules have mostly been changed, you can see the effect of that history on the data today. and you can sort of see the distribution of people within the city. If I remove the map labels, you can still see the lakes and the rivers and the highways. I think it's a really beautiful visualization. Another visualization that I really like, this is partially because it was inspired by me, is this visualization of guessing names based on what they start with. So this is a piece by Nathan Yao, and I can see a connection to this class because it's sort of like the probability of a particular name given that you were born in a particular decade, or the probability of a particular name given that you were born in a decade and your name begins with a particular letter. So here is the data visualization, and you can say, you know, I'm a female, I was born in the 1980s, and since it says I don't know what your name starts with, I'm just showing the most common names. So if you just give it the information of the decade, then it'll make the guesses, but then I could put that my name starts with AM, and it's gonna say, I'm guessing your name is Amanda. It's got a 50% chance of being right. If you're a female, born in the 80s, your name starts with AM, I'm pretty certain. And actually, this is the first name that I get called the most, is Amanda, even though my first name is Amelia. So this is kind of a fun, interactive data visualization that you can try out with your own decade and name.